Technology. It's advancing faster and it's taking less time to be widely adopted than ever before. Like how it took roughly 10,000 years to advance from writing to printing press, but only about 500 more years to advance to email. Now, it seems that we are at the dawn of a new age, the age of AI, the age of artificial intelligence. Welcome to our presentation. I'm Goh.
I'm Chin Wei.
I'm Jen Nam.
And we'll be introducing you to our research, where we try to utilize LPR technology with AI to improve traffic systems. Shown here is the overview of our project, where we'll talk a bit about research objectives, problem statement, methodology, novelty of our research, discussion, and conclusion. Without further ado, let's jump right into it. Let's start it off with a simple question. What is AI? Artificial intelligence is the ability of a computer or a robot controlled by a device to do tasks that are usually done by humans because they require human intelligence. Its system's ability is to adapt and improvise in a new environment, to generalize its knowledge and apply it to unfamiliar scenarios. Now, for our research objectives. In our research, we aim to increase the effectiveness of traffic systems, to reduce the amount of carbon emissions, as well as improve the security of the current tollway systems. When we started this project, we began by searching how we could implement AI to solve our problems, maybe worldwide destruction or minor inconveniences. One particular problem that we see almost every day in Malaysia managed to catch our attention, which is the massive amount of traffic congestion. According to one study, traffic congestion has increased substantially in urban areas since the 1950s. Congestion is a condition in transport that is characterized by slower speeds and increased vehicular queuing. It occurs when traffic demand is high enough that the interaction between vehicles slows the speed of the traffic stream. Besides this, numerous negative effects also occur along with it. This includes delays in schedules which may result in late arrivals, wasted fuel, wear and tear in vehicles from long waiting times, increased chances of accidents, and various road rages. We identified two main causes for this problem, the first one being tollway traffic. In this scenario, vehicles have to slow down or completely stop for the toll collection. Not only that, the amount of tolls and roads are not parallel, resulting in traffic diversions. Besides toll traffic, parking lots are also one of the reasons. Huge parking lots can be very confusing for a lot of people, and parking toll gates are also quite inefficient for the same reason as toll collection. Here are some statistics that showcase how inefficient our current systems are. From the first table we see here, we found out that the average toll transaction time was around 5 to 6 seconds, which translates to around 550 to 620 vehicles per hour. From the second graph shown here, it showcases an emission speed graph. From here we can see that the curve shows high emission rates at low and high speeds, but low emission rates at moderate speeds. By combining with the previous statistic, another inference can be made. If vehicles spend more time on toll collection, the average vehicle speed will reduce and CO2 emissions increases. This creates a domino effect where vehicles will spend more time on the road, which results in higher CO2 emissions. Therefore, in this scenario, by mitigating traffic congestion, we will directly reduce CO2 emissions.
Now, you all probably have a rough idea about what we are trying to achieve. If not, let's get straight into it as we will be revealing about our project.
Our solution to it is utilizing a vehicle's identity, its license plate. As a citizen of a great country, we must have an identification card to distinguish and verify our identity. A vehicle's license plate gives it a unique identity, much like how our identification card distinguishes us from foreigners. Having a license plate is similar to a car wearing its identification card. With this in mind, why didn't we put the identification card of these automobiles to more use? Having said that, you're probably wondering how we are going to utilize them. Well, get ready and buckle up, since it's going to be a new and bold adventure. In our project, we included two AI technologies, which are visual AI, image recognition, and text AI, license plate recognition. Before proceeding, let's investigate more about image recognition and license plate recognition. So what is image recognition? It is an interdisciplinary scientific field that deals with how computers can gain high-level understanding from digital images or videos. From the perspective of engineering, it seeks to understand and automate tasks that the human visual system can do. But what is license plate recognition? Let me explain. It is a technology where characters from video footage are automatically recognized and recorded for security and traffic analysis purposes. In this case, every vehicle license plate that got captured by the camera setup is processed by a series of pre-programmed algorithms that are tasked to recognize and generate alphanumeric data from the license plate images into text entry. Without further delay, let's jump right into our concept. This is a camera equipped with image recognition and license plate recognition technology. At first, the camera will automatically scan the car plate, model, and color for verification. It will contact the platform to deduct the balance from your personal account. This is a simple flowchart to showcase the system. At first, the system will start when the camera senses your license plate at a tollway or car park. It will verify the model and color of your car with the account linked to your license plate. Once the verification process is done, the system will automatically deduct the balance from your account. The app will notify the transaction to you, and you can terminate your account if you find any suspicious activity. And this is the app preview for our system.
Okay, after we got that out of the way, let's see what makes our project different and unique from the current systems. The first one being the way we try to utilize image recognition. We normally use image recognition for drones, manufacturing, military surveillance, forest activities, etc. But the way we utilize image recognition differs greatly from its current usage. We use it along with text AI, which is license plate technology, and utilize it in the field of traffic. Keeping that in mind, here are some reasons why our system will be better than the existing ones. First of all, compared to touch and go and RFID, which requires you to buy a tag or card, our implementation is completely free to the masses as all vehicles are already equipped with a license plate. Besides that, since our system only needs a license plate, it's much safer compared to tags and cards that can be lost or stolen easily. Other pros and cons can be referred to the slide. Now, we'll show you our interpretation and description for our research project. First is our security system. When a car theft happens, the user can report the incident in the mobile app. The system will then terminate the account and terminate the car. After the owner's car is recognized by our system, the car won't be allowed to pass by any toll or car park transaction. The app will immediately inform the owner and notify the emergency services. What if the user has the incorrect car linked to the license plate? Users will need to confirm their identity by using the mobile app. If the original owner denied the system's confirmation, the car won't be allowed to pass by any transaction as mentioned just now. The system will automatically blacklist the car and report to a nearby police. If the color of the car changes, the user will need to change the description of the car in the mobile app. If not, the system will detect the wrong model of the car and the user will need to confirm his or her identity in the app before continuing the transaction at a tollway or car park. If the color of the car has discolored, the system will utilize the machine learning and quickly adapt to the minor changes to the car. If there are major changes, users will have to confirm their identity on the mobile app before continuing the transaction. Well, that was quite an eye-opening experience, so let's wrap up our presentation with some closing remark. From our project, we are trying to achieve three things. One is for our concept to expand into various domains that can be used in various ways. For example, crowded waiting areas, such as schools, train stations, and airports. We also hope that our project can collaborate well with the vehicles of the future, as we believe it can withstand the passage of time and benefit the future generation. Last but not least, we hope that our project can play a part in shaping our country into a stable, high-income and innovative country. That's all from us. Thank you for lending us your ears.